Good evening, students. Today's class is on tree traversals. Okay, already from the last 3 days, you are listening of binary trees. Okay, binary trees is nothing but each and every node in the tree has a two subchains, that is left node and right node. So each and every node has three values: a left subtree pointer and right subtree pointer and a data value. Okay, so each and every node is represented with the three parts. Okay, we already know the traversal is nothing but displaying the values. This already we used in the linked list, traversing of the single linked list, double linked list and circular linked list. Okay, as in the same way for the trees also we have the traversals, that is displaying of three elements of the binary tree. Okay, for this traversal of the tree, we have the three types of traversals. First one is inorder traversal, second one is preorder traversal, third one is postorder traversal. Okay, so inorder traversal is we get the root node in the middle, and preorder traversal is root node in the left, and postorder is root node in the right side. That is, in order is in the middle we will traverse the root node, and preorder is first we will traverse the root node, then the left and right trees, and in the post order we traverse the left first, then right, then root node. Okay, so I will check in detail this traversal process. Okay, so in order traversal can be called as first the left subtree is traversed, then root is traversed, then right subtree. The preorder first root is traversed, then left subtree, then right subtree. In the post order traversal, first left subtree, then right subtree, then root node. Okay, so I will see this these three techniques with an example. Okay, okay, this is the preorder example. Okay, there's a one binary tree which is already represented with all the required nodes. Okay, we are going to traverse the preorder. Okay, preorder is nothing but first is the root, next is the left subtree, next is the right subtree. That is, root must be traversed first and will display it. Okay, so I will traverse the one by one node and will show the output here. Okay, so for this, for easy understanding and for easy traversing of the tree, okay, write down like this. For each and every node, write down the root left and right, root left and right, root left and right. For each and every node, write down like this: root left and right. Okay, you will be easily remember that the preorder is nothing but first root, then left, then right. Okay, so and strike out the whatever the thing you have already traversed, strike out that. If you are traversed the root, strike out the root. If you are traversed the left, strike out the left. If you are completed the right, then traverse the right. Okay, so I will do that. Okay, first we are starting from the root node. The main root node of the tree is the 1. So first we will show the root node because it is a pre-order traversal. Show the root node 1 in the output. Okay, and strike out the root. Okay, so next check whether the node has left subtree or not. Okay, root is completed. Now check whether it is having a left subtree or not. For this tree there is a left subtree. Okay, so I will move to the left subtree. Okay, so now we are coming to the 2 node. Okay, now we are on the 2 node. So first display the root node, that is show the 2 on the output, and check whether this node has left subtree or not. Okay, this is having a left subtree. So move on to the its left. Okay, next. Okay, 4 node, display the 4. That because we need to show the first root. So display the 4 in the output. Okay, next is check whether it is having a left subtree or not. Okay, 4 node has the left subtree. This is the left subtree for the 4 node. Okay, now, so we are moving on to the 7 node. Now show the 7 node value. Okay, 7 node and strike out this. It's completed. Okay, 7 is on the output. Okay, now check whether the 7 has the left subtree or not. Okay, there is no left subtree for the 7. Okay, so strike out that. Okay, and check whether it is having a right subtree or not. It is having a right subtree. So coming to the right. Okay, so now we came to the right and displaying the root node. Okay, okay, root node is 9. Okay, just we will see how we are striking out the each and every node pointers. Root and left, right. Okay, 4 is not, there is no right node for the 4, so we have striked out the 4 right also. Okay, next 7 is over, so root is strike out. Left is over, so strike out. Now go to the right. Okay, in the right side we have the 9. Show the 9 in the output. Okay, 9 is on the output. Okay, now strike out the root in the 9, and there is no left subtree for the 9, so strike the left, and there is no right subtree, so strike out the right. Now go back. Okay, from here we'll go back to the 7. Its right is completed, so strike out. And now go back to the 4. Its left is over, right is over, so strike out the right. Now go back to the 2. Its root is over, left is over, and there is a right subtree for the 2. Okay, so we'll wait for here and we'll move on to the right of the 2. Okay, 5. Okay, displayed the 5. So it's 5 root is over, left is, there is no left subtree and there is no right subtree. Now move back to the 2. Its right is over, so strike out. Now move back to the 1. Its left is over, so strike out. Okay, next 1 is having a right subtree. Okay, there is a right subtree, so we'll move on to the right. Okay, now whenever you are moving to the right, okay, there is a node is the 3, so its a root is 3, so strike out. Sorry, okay, 3 is on the right, so display the 3 on the output. Next move on to check the whether the left subtree is available for that. 3, there is no left subtree, so and check whether it is having a right subtree. It is having a right subtree, so move on to the right and display the 6 in the output. Okay, okay, now we'll show the 6 in the output. Then we'll check whether the 6 is having a left subtree or not. There is no left subtree for the 6, so and there is a right subtree, so move on to the 8 and show the root node, that is 8, and check the left subtree. There is no left subtree for 8 and there is no right subtree for 8, so we completed the 8. Okay, root is displayed and left, there is no left and there is no right. Move back and its right is over, so strike out, and move back, its right is also over, 3 right, move back. Okay, strike out and go back to the 1 and strike out the right of the 1. Okay, now check the striking of our nodes. Okay, next it move on to the 6 and display the 6. The root is over, strike out, there is no left subtree, strike out, there is a right subtree, so move on to the 8 and display the 8 in the output and strike out the root, and there is no subtree, so left strike out, and there is no right subtree, so right strike out, and move back to the 6 and completed the right, so strike out the right. Then move back to 3 and strike out the right because right is completed. Then move back to the 1 and completed the right, so right strike out. So like this, whenever you complete a striking out of all the nodes, okay, then your result is your pre-order result of the tree. Okay, this will make us to prepare the traversal properly, and we can complete all the nodes traversals in a proper order. So next we'll see the inorder traversal. Okay, start from the root node, that is 1, and check whether the each and every node has the related subtrees or not. Okay, And for the inorder, we require the left to be traversed first, then root, then right. So write down like this for all the nodes, left, root and right. Okay, write down for all like this. Okay, now start from the 1. Okay, check whether there is a left subtree or not. There is a left subtree, so move to the 2. Then check for the true whether there is a left subtree, and it has the left subtree, so move to the 4. Then check for the 4 whether it is having a left subtree or not. It has the left subtree, so move to the 7. And check whether the 7 has the left subtree. Okay, there is no left subtree for the 7. So strike out the left and display the 7 in the output and strike out the root. Now check whether the 7 has the right subtree. It has the right subtree, so move to the 9. Okay, and display the, check the left subtree of the 9. There is no left subtree for the 9, so display the 9 and check for the right. There is no right subtree. Okay, so 9 is displayed in the output. Now move back to the 9 to the 7. The right is over, so strike out the 9. Okay, and move back from 7 to 4. Left is over, so strike out the left and display the 4 in the output. Okay, so root is over. Now check for the right. There is no right subtree for the 4, so move back to the 2. So for the 2 node, left is over, so strike out the left and display the 2 in the output. Okay, strike out the root and check whether there is a right. There is a right node, so move to the 5 and display the 5 node, because there is no left for the right, 5 node, and there is no right. So strike out the left and right and display the 5 in the output. Okay, now move back from the 5 to the 2. Okay, its right is over, so strike out. Next move back from 2 to the 1 and its left is over, so strike out the left. Now we are displaying a 1 in the output. Strike out the root and next we will move to the right of the 1. Okay, now right of the 1 is 3 and there is no left subtree for the 3, so strike out the left and display the 3 in the output. Okay, next move to the right of the 3. Okay, there is no left subtree for 6, so strike out and display the 6 in the output. Okay, strike out and go to the next node, 8. There is no left for the 8, so strike out and display the 8 in the output and strike out the root and strike out the right. Now move back to 6, completed the right, so strike out the right. Move back to 3 and right is over, so strike out. Now move back to the 1, so its right is also over, so strike out. So all the nodes are striked out, and this is the result of our inorder traversal. Okay, this is the inorder traversal result of our graph, our tree. So now we'll see postorder traversal. Postorder traversal. So for the postorder traversal, we'll write there like left, right, and root. First left to be completed, then right to be completed, then root to be displayed. Okay, so first we'll start from the 1 and we'll check whether there is a left subtree or not. There is a left subtree, so move to the left of the 1. Next check for the 2. Is there left subtree or not? Is there left subtree, so move to the 4. And 4 has also left subtree, so move to the 7. And for the 7 there is no left subtree. Okay, so strike out the left and check for the whether there is a right subtree for the 7 or not. There is a right subtree, so move to the right. And for the 9 there is no left subtree, so strike out. There is no right subtree, so strike out and display the 9 in the result, so strike out. Okay, now I will move back to the 7. Okay, now display the 7 because its left is over, right is over, display the root. Now move back to it, 4. Display the 4, strike out. Next move back to 2. Its left is over, so move to the right. And 5 right, there is no left, there is no right, there is root. 5, display the 5 and move back to 2. Its right is over, so display the 2 in the output. Then move back to the 1. Okay, its left is over and we'll move to the right. Okay, right of the 1. So it's a 3, 6 and 8. Display all and move back